the principal quantum number. Remember, we have explained what is quantum number. Today we'll look at the principal quantum number. What is this principal quantum number all about? Now, note that the principal quantum number has about 3 important, let's say, functions. Okay. The first one is that it defines the energy. It defines the energy of an electron. Okay? It defines the energy of an electron. That is the number one thing you have to know about the principal quantum number. It defines the energy. That's the first thing. Let me just circle this. Number one, it defines the energy of electron. Now, these principal quantum numbers are sets of numbers ranging from 1. It starts from 1, goes to 2, goes to 3, and 4, and so on. Now, how does this number define the energy of an electron? Remember that if I have an atom having the center here, remember the center is the nucleus, remember, which contains the proton and the neutron. Revolving around this are electrons. Electrons are in shells. So electrons can be here, it can be here, it can be here, it can also be here. So each of these things are energy levels. So each of these electrons are assigned quantum numbers starting from 1. The first shell indicates that the principal quantum number is 1. The second shell indicates that the principal quantum number is 2. The third shell indicates that the principal number is 3. Now, these numbers tells us the energy of each electron, because if we can be able to denote the particular shell or energy level or the particular quantum number that an electron has, we can be able to find out the energy of the electron. Remember that as you move from the first shell to the second shell to the third shell, the energy increases. So electron in the principal quantum number 3 and principal quantum number 1 will not have the same energy. Okay? So this quantum number help us to know the energy of an electron in the orbital. So now, that is number one function, okay? Or number one importance of the principal quantum number. The second important thing that the quantum number tells us is that it denotes the shell that the electron is present in. For example, just like I've told you, remember, I know that some of you have seen this in your textbooks, something like this. Watch. This is what we call shell. This is N, which is your principal quantum number, okay? And the number starts from 1. They are integers. 1, 2, 3, 4. They keep going on 5, okay? So if this N, how does the principal quantum number tell us the shell? Any shell that has a principal quantum number 1 is definitely a K shell, okay? Remember, we have the shells in chemistry: K, L, M, N. We also have the O and the P, but I will stop here for now. Okay? So if a principal quantum number is assigned 1 for an electron, definitely the electron is in the K shell. So the principal quantum number tells us the shell that an electron is present in. Number 1, it defines the energy of the electron. This is number 1, you have to know. Number 1. Number 2, it tells us the shell. Okay? It tells us the shell. So note these 3, these 2. Okay? Number 1, it defines the energy of the electron. How does it define it? By the number. If the number is 1, it means that the energy is at the lowest state or at the ground state. If it's 2, it means that increased energy. So as you keep going from 1 to 2 to 3 to 4, the energy level increases. As you keep coming down, the energy level does what? Decreases. Remember, most times, that this principal quantum number, as time keeps going on, I will link it to how to use it to understand energy levels in what? Electrons. Okay? So take note, the first one, it defines the energy of the electron. Second one, it tells us the shell. How does it do that? On the board here. The last one is that it is used. Number 3, the last important function is that it is used to calculate maximum number of electrons. Okay? It is used to evaluate the maximum number of electrons using the formula. Take note, the formula we use to do this is given as 2n squared, where this n are quantum numbers ranging from 1, 2, 3, 4. So if I know the value of the n, I can work out the maximum number of electrons in a shell using this formula. So take note, this formula is very, very important. Note it down. So whenever you are asked to calculate the maximum number of electrons in a shell and the principal quantum number is given to you, you can find the maximum number of electrons. For example, how do I know that? Watch. Let's assume that the n is equal to 1. Using this formula, what should be the maximum number of electrons? We have 2 into 1 all squared, which is equal to what? 2. The total number of electrons in the shell or in this n equal to 1 is 2. So take note, the principal quantum number has 3 important functions or 3 important features. Okay, the first one is that it defines the energy of the electron. It tells us the shell by knowing the shell from the what number. Number 3 is that it is used to calculate the maximum number of electrons using the formula 2n squared. And I gave example, if n is 1, you can evaluate this and get 2.